book, to me, overcomplicates this a little bit. You have all the knowledge to solve this problem already. The book says, hey, here's some formulas. Would you like to memorize them? It's truly not a time saver when you have your knowledge. You're very smart. So check this out. 4, -5 is a point on the terminal side of theta in standard position. Find the exact value of the 6 trigonometric functions for theta. So if you have a dot at 4, -5, we have everything we need. You know how to solve things with the Pythagorean theorem, so you can get missing sides. We know that it is going 5 in this direction because the point is -5. But honestly, we are going to call it -5 there because we are in that section. So even though technically a side length couldn't be -5, we're not making a real triangle. We're just using our knowledge of triangles to find some missing zones. So it's also 4 to the right here. So this side of our imaginary triangle is 4. We're missing the hypotenuse. Okay, so we can figure out the hypotenuse of something by doing one side squared, 4 squared, plus the other side squared. And here's why it doesn't even matter that we had it as -5. Equals the third side squared. 4 squared is 16, 5 squared is 25, -5 squared. That'll add up to 41 equals c squared. So if we square root both sides, that means our hypotenuse is the square root of 41. So let me label that as root 41. So now we have actually all the information we need for the 6 trigonometric functions. So let's try this out. Sine theta is the opposite, -5, over the hypotenuse, which was root 41. Now, we can never have root 41 in the denominator, so we can multiply by root 41, root 41. The numerator would be -5 root 41 over regular 41. Cool. Cosine would be the adjacent side, 4, over the hypotenuse, which is root 41. We will get rid of the root 41 by multiplying root 41 in the numerator and denominator, giving us 4 root 41 over just 41. Now let's get that tangent. Tangent is the opposite, -5, over the adjacent, +4. Cool, nothing to do there. All right, now we got to get our other 3. So remember, sine went with cosecant, and it was the reciprocal. Now, you can flip -5 root 41 over 41, and then you're going to have to do the radical trick again. But if you look right here, oh, come on. If you look right here, it was -5 over root 41. If we just flip that part of it over, it would be root 41 over -5, which, remember, you just write the negative in the numerator. So negative root 41 over 5. So take it back to the step before you rationalized the denominator and flip it. Save yourself some time. So if we did that, then for cosine and secant, cosine was 4 over root 41. That would make it root 41 over 4. Nothing to simplify there. And tangent, we can just go ahead and flip it for our cotangent. -4/5. That's all done. So I have another one for you to try on the next slide. I'm running out of time now. So go ahead and give it a whirl. I'll flip it to the next slide here.